Hi there. For this video, we'll be talking about quadratic inequalities. So now that we are done with linear inequalities, a good question to ask is, how do we deal with quadratic inequalities this time? So again, when we talk about quadratic, a polynomial is quadratic if there is a degree of 2, that, or if other variables we have y squared and so on. So basically we're dealing now with degree 2 polynomials. To answer that question, the key is with critical points. So what are critical points? So we'll dive into that later, but this is the thing that we need to keep in mind in order to solve the problems on quadratic inequalities. So what are critical points? Well, if we have a x minus 2 and we equate this to 0, then we know that the outcome is x equals 2. So let's plot that one. And from here, observe that in x minus 2, if we plug in values from the left side of this point, the outcome will be negative. Indeed, if we plot in here x equals 1, then the outcome here will be 1 minus 2 is equal to negative 1, so it's negative. If we plot in 0, we'll have 0 minus 2, which is negative 2. So all values on the left, when plugged into our given expression, the outcome will be negative. On the other hand, if we plug in the values on the right, the outcome will always be positive. Indeed, if we try 3 minus 2, the outcome is 1, which is positive. If we try out 5 minus 2, the outcome is 3, which is positive. So essentially that is how critical points work. This is like the point wherein the value of the given shifts. So out here we have negative, and out here on the right we have positive. So how will we apply this in our quadratic inequalities? Well, our goal in our quadratic inequalities is to be able to factor our quadratic expression into, say, x plus a and x plus b. And if this is less than 0, or whatever inequality it is, what we'll do is we'll get the critical point for this one and the critical point for this one. We plot them in the number line and observe each region divided by the critical points. So we can better visualize this with an example. So let's have this first example. Let's have x squared minus 2x is less than 8. This is quadratic since we have a degree of 2. So the first step, since again our goal is to make this like this, wherein this one is 0. Since that is our goal, what we do is we first move this to the left. So we will obtain x squared minus 2x minus 8 is less than 0. And just a quick note here, we want one side of the inequality to be 0 since it's easier to observe at 0, since at 0 at the left side is negative and at the right side is positive. So zeros are really helpful in inequalities. Now from here, next step is to factor this one. With our factoring knowledge, you can verify that the correct combination will be x minus 4 and x plus 2. And now here we have our two factors. We have this first factor and second factor. We now get the critical points for each of these factors. Similar to how we did in the illustration, what we'll do is we'll equate this one to 0. So x minus 4 equals 0 will give us x equals 4. Then x plus 2 equals 0 will give us x equals negative 2. Now that we have this, we'll plot it in a number line. So let's assume negative 2 to be here and 4 to be around here. And just take note and divide these regions into these critical points out here. So we have this first region, second region, and third region. Now let's start with this first region. What we'll do is we'll test some values on this region and plug it into our given and check if this condition is satisfied. So what is a good test value out here? Well, a number less than negative 2 can be negative 3. So we'll have here negative 3 minus 4 times negative 3 plus 2. So basically I plugged it the negative 3 out here. This will give us negative 3 minus 4 is negative 7 times negative 3 plus 2 is negative 1. Multiplying this will obtain 7, which is not less than 0. Therefore, the region out here is false, or we won't consider that in our final answer. Let's now go on to this next region out here. So what is a number that is between negative 2 and 4? Well, we can take 0, since this one is negative, this one is positive. So indeed, 0 is in between these two numbers. So at 0, x equals 0, we'll have 0 minus 4 times 0 plus 2. This will give us negative 4 times 2. Negative 4 times 2 is negative 8, which is less than 0. So the region out here is true, since we got a value that is less than 0. Let's go on to our last region, which is this one. So what is a number greater than 4? We can take 5. So at x equals 5, we'll have 5 minus 4 times 5 plus 2. This will give us 1 times 7, which is 7. And again, this is not less than 0. So the region here is false. Therefore, the only valid region that we got is the region at the middle. Therefore, we say that the solution set for this one is x is between negative 2 and 4 without them included, or what I mean is negative 2 and 4 are not included since we don't have an equal to in our inequality. So basically, it is strict. If you want to express our answer in interval notation, we'll have negative 2, 4 with parentheses, not brackets. And this one out here is the answer for this problem. There. Let's go on to our second example. In this example, we have 3y squared minus 7 is greater than or equal to 5 times y plus 1. So applying the same idea, our first goal is to make one side 0 and move every term on the left side of the inequality. First, let's simplify this. So we'll obtain 3y squared minus 7 is greater than or equal to 5y plus 5. After that, we move these to the left side. So we'll obtain 3y squared, 5y to the left will be negative 5y. Then we'll have negative 7 minus 5 is negative 12 is greater than or equal to 0. Next, we factor this one out here. And how do we factor this one? Well, we can apply the slide and divide method, which I'll leave with you to verify. The right combination for this one is 3y plus 4 times y minus 3. Yep. And if you are wondering how to get that, I'll probably link a video around here on how to factor quadratic trinomials. Specifically on the last part of that video, I explained how to use the slide and divide method to factor trinomials with a coefficient in the beginning. So check that one out. And this one will be greater than or equal to 0. Now, let's fix this. Now that we've got what we want, next step is to check the critical points or to get the critical points. So for this one, we'll have 3y plus 4 equals 0, or that will give us y equals negative 4 over 3. For this one, y minus 3 equals 0, or y equals 3. So plotting these points in our number line. So we've got here 3, and we've got here negative 4 over 3. Somewhere around there. And again, we'll divide this region into 3 parts. So region 1, region 2, region 3. Starting with our first region, let's test out some values. Let's find a value less than negative 4 over 3. We can take negative 2. Yep, negative 2, since negative 4 over 3 is approximately negative 1.333, I think, if I'm not mistaken. Then at y equals negative 2, we'll have 3 times negative 2 plus 4 times negative 2 minus 3. This will give us negative 6 plus 4 times negative 5 and negative 2 times negative 5 or simply 10, which is greater than or equal to 0. So the region out here is true, since we got the inequality that we want. For the next region, let's have this region out here. So again, since this one is negative and this one is positive, then we can take y equals 0, since we are sure that it is in the middle of a negative and a positive number. So at y equals 0, we'll have 3 times 0 plus 4 times 0 minus 3. This will give us, this one will just be 0. So we'll have here 4 times negative 3, which is negative 12. And as you can see, the inequality is not satisfied since negative 12 is not greater than or equal to 0. Therefore, the region here is false. For the last region, we have this region out here. So a good test value is a number greater than 3. That can be 4. So we take 4. At y equals 4, we'll have 3 times 4 plus 4 times 4 minus 3. This will give us 12 plus 4. 4 minus 3 is 1. Then 12 plus 4 is simply 60, which is greater than or equal to 0. Therefore, the region out here is true. And so with that, we can conclude that we have two valid regions out here, not considering this one. So we have our final answer to be y is less than or equal to, since we have an equal to out here, y is less than or equal to negative 4 over 3, or y is greater than or equal to 3. Since we have these two regions, so this one out here represents this region, and this one out here represents this region. In interval notation, we can write this one as negative infinity to negative 4 over 3 with a square bracket, since we have equal to, union 3 to positive infinity. And those are our answer for this problem. There. Now, here are two exercises that you can work on. So in the first one, we've got 7 squared plus 4 is greater than 4z. And for the second one, we've got v squared plus 7v plus 10 is less than or equal to 0. So you will apply the same concept or same idea that we had in the two examples in this video. So that's it. I hope you enjoyed this one. Feel free to comment down below your solutions and answers to these exercises in the comment section down below. That's it, and that is all for this video.